Hello, hello. So, this is 10 p.m. in Japan time on Saturday. This is Junichiro Horikawa. I would like to start a tutorial live for this week. I couldn't do the live on Wednesday, so I'm gonna do this today on Saturday. And the topic, and this is the weekly tutorial live for Houdini, which is called as Houdini Algorithmic Live, and this is the 75th episode. And the topic for today is to create this kind of a recursive branch in 3 dimension, as well as a running vein-like path on top of this surface, like this. Okay, so I'm going to create the vein by using some recursive method looking like this, with some parameters which you can change. Then create a 3-dimensional geometry like this one from these curves. Then using a rather simple method to run a animated vein like these, or kind of a trail like stuff on top of a surface. Okay, so that's what I would like to do today from scratch. Okay, so let's do this. And it's not going to be that hard, I think, but I do use a lot of vex, as always. So, let me first explain how I'm going to do in a flow, maybe in a sketch. Let me try to draw what I'd like to do today. Let me check. Let me see. So, first of all, in order to create a recursive branch, or like a tree-like shape, I'm going to start by creating a line like this, and then create a tons of points on top of the line. Then what I'm going to do to these points, I'm going to use a noise function to move the points randomly on a x direction. So as a result, I'll get a curve, a symmetric curve like this, and this is going to be the initial curve that I'm going to use to create a curvy branch or curvy tree. Okay, I have a question from Ballarts. What really does it mean to be recursive? Okay, so being recursive means you do the same process over and over again to create. This is a process that you do over and over again by using the last retrieved value for the new value. In this case, this is the first value, the initial value. Now the next thing you'll do is to set the starting point from this initial curve. In this case, for example, let's say I'm going to pick some random points, number of random points from this branch, like this point and this point, and what you can get from this point is the information called tangent vector, which is the vector value of the gradient of this curve. Okay, if it's this part, then it looks like these. Then by using these information, what you can do is to do the same step for step 1 in the next step from each of these points. What I mean is that in this direction you draw another line, which is a step 1, and then you create another curvy curve which is a step 2, and you continuously create this process over and over again as much as you want. Then in the end you'll be able to create a very complex tree-like, curvy-like shape. And this iterative method, this process, which is using the last created geometry as the seed for the next geometry, or the process, is called as recursion, and called as recursive process. Okay, so let's do this first, and then after doing this basic recursive tree, creating this recursive tree, what I'm going to do next is to thicken this tree, this curve, to create a geometry. I'm going to use the PDV to create a simple thickened geometry, and I'm going to create a polygonal shape on top of this geometry. Sometimes it's hexagon, sometimes it's octagon, and so on, by using a really simple remeshing technique. And I'm going to use these hexagonal or octagonal or heptagonal shape as a path for the vein, starting from bottom to top. Try to create a running vein on top of these curve. Okay, and that's probably it for today, and if I have more time, maybe I can use these running vein as an information to make it as a trigger to run another simulations like coral growth or something like that. But maybe that might be the topic for another time. Today I'm just going to create this kind of animation using Houdini. Right, so let's see. Okay, I'm going to start by creating a geometry node, and starting by creating a line first. Right, as I said, I'm going to create a lot of points on top of this line, so currently there's only 2 points. I'm going to create 50 points. Okay, and we'll like to move these points to X direction to make it as a really curvy curve. For that purpose, I'm going to use the point wrangle. Okay, at the same time, I'm going to create a null node so that I can control the parameter that I have created to control all these shapes. So let's open up the edit parameter interface for this controller, move it aside for a while. Alright, so for the point wrangle, I'm gonna name it as init curve. Okay, what I'm gonna write here is pretty simple stuff. I'm going to try to first create a vector value moving these points on X or maybe on Z direction as well. So let's try to create a three-dimensional vector value from a noise function. So vector direction is equal to noise based on the point position. And by multiplying the point position with some float value, you'll be able to control the smoothness of the curve or the directional move based on the position. Okay, and you probably might want to also control the variation of the curve. So I'm going to add another parameter, adding the parameter called shift, so that you can shift the value to change the variation of the value, the variation of the curve shape. So something like this. And the value you get out of this function when you want a directional value, this is a vector value which is in between 0 to 1 for all x, y, z coordinate. But instead, I also want to have the value in negative direction as well for x, y, and z. So by subtracting with 0.5 for each coordinate, you'll be able to get a value in between minus 0.5 to positive 0.5 for all each x, y, and z. Okay, and in this case I don't want to move in y direction, I just want to move in horizontal direction, which is x and z direction. I'm going to make the y value to 0. Okay, now the vector has been created. I can now just move the point position with the directional value that I've just created with some moving value to determine how much you want to move in this direction. Alright, so I have now 3 parameters. Let's try to raise up this move value to 1 for now and try to raise up the smoothness. You can see that more smoothness you have, more detailed the noise will be, and by changing the shift you can change the variation of the smoothness of this noisy curve. Now let's raise up the range, the smoothness to 0 to 10 or maybe 2, I don't know, 3. Shift to 10, move to, I don't know, 2. So something like this. Maybe I can raise up the smoothness a little bit more to 5, I guess. Right, so looking good. It's just each of the point is just moving on XZ plane with some amount using the noise value, making a curvy shape like these. Okay, let's make it something like this. Alright. Now, next, I am going to make this line to have initial group called as a last group. But before, I'm going to open up the edit parameter interface for this controller to pass all these parameters that I've just created for initial curve. So I'm going to drag and drop these parameters and rename this. Let's say these are the parameters for the initial curve, so I'm going to create a label on top of this 3 parameters, calling init curve initial curve. Okay, I'll be able to have these parameters set in one place. That's good. Alright, now let's create a group node. And called as last. And I'm going to use this last group or group called last inside a recursive method to determine which line or which curve is going to be used to pick the point and be the parent branch for the next process. I have a question from Valots. Are these going to be raised up on the surface? So the variables you wrote, they work only on the noise functions by themselves. They mean nothing, right? Smooth, shift, they do nothing until they are bundled to the noise. Yeah, that's correct. That is correct. Just don't get how you reference them to noise data. Yeah, these are just the custom value that I have created for myself, applied to the function, to the noise function. So it's not really related to nothing else, just to this noise function and the directional value. Okay, now that I have created the group, let me also create some attributes that I'm going to use inside a recursive method. I'm going to use a attribute create. And the attribute that I'm going to use is the p scale, which is necessary for controlling the width, controlling the radius for each point on the line to create the final geometrical shape using a BDB. So p scale, and initial value I'm gonna set as 1. Okay, let me also save this file somewhere. Okay, recursive branch. Wait. Okay, I have a comment, but how do you set the path to the noise? That always seems to confuse me. Path to the noise. I'm not sure what you mean by the path. How do you set the path to the noise? Or you mean this channel to this value? Well, if you mean by these one, by writing chf with the function and you press this button, you'll be able to promote these channel, you'll be able to create these channel automatically, which links this one and this one, this value. In this case, this value and this value. You can also create manually by going into the edit parameter interface, drag and drop these parameters by yourself. And when you want to call these channel, you look at the type of the parameters. In this case, this is the float value. Everything is float in this case. In those cases, you write CHF, meaning channel float, in vex to call those parameters, so that this value will be read inside of vex. So in this case, 2.049 is going to be replaced with this one, 3.46 is going to be replaced with this one, and so on. And then again, if you look at the controller node, I have the same parameters, and I have copied this parameter, then paste this as a relative reference, meaning it is reading the controller's parameter, meaning if I change these value, this value also changes, and this value is going to be used as a value inside of X. I don't know if that answers your questions, but that's how it works. Okay, now, so this I think I have done with the initial setup. Now I can go inside. Now I can start to set up the recursive process using a for loop. And this method is pretty general for all recursive method. If when you want to create a fractal shape or so on. Things that I'm gonna do next is pretty much general. So first I'm going to use a for each number node. I'm going to connect like these. And for the for each end, I'm going to change this gather method to feedback each iteration. And then change the for each begins method to fetch feedback. The combination of this feedback each iteration and the fetch feedback will enable you to create a recursive method using this for each loop in a static setup, or in one frame, in a single frame. If you want to create an animated recursive method, maybe you can instead use a solver instead of this for each loop, and just write the same functions inside a solver you write inside a for each loop, and you'll be able to create an animated recursive process. Now in this case, I don't want to make it as animation for this process, so I'm going to use this for each loop. And when it says 10, this means that you do the same process 10 times, but it's safer to start from a small number of process, a small number of iterations. So I'm gonna stop by from one. Okay, now first thing first, what I'm gonna do is to calculate the tangent vector on top of this curve so that I can get the tangent vector on each point. Currently I don't have those information, so to do that, I can just use a node called polyframe, which you can create a tangent vector as well as a normal direction. The normal direction doesn't really mean anything in this case. What you need is this tangent u value. Okay. So let's check this tangent vector value out, visualizing it to see in which direction this vector runs. You can do that by going into this visualization, to the scene, create a new marker for the tangent. Setting this style to vector value. Okay, so this yellow line is indicating which direction this tangent vector is running. And as you can see, this is running in this tangent direction from each point. So this direction is going to be the guide value to create a next line. Alright, looks good. Now, next thing I would like to do is to actually create a new branch from this curve. And there is a chance that in few steps after, a few iterations after, you are getting a multiple number of branches. So for each branch, you want to do the same process. Again, for that purpose, I'm going to use the primitive wrangle to work on each curve, which has the last group. I'm going to filter the primitive wrangle with the last group. Also going to reference the for each count node, which have these information like iteration on detail attribute, like these one. The iteration indicates in which iterations you're in when these wrangle is going to be processed. In the first iteration is going to be 0, and the next iterations you'll get 1, and so on. I have another question. Is there a way to find tangent using vex only? Okay, that's a good question, I think. I think so. In order to get the tangent with the vex, what you need is the neighbor information from the point. Okay, in this case, let's say you want to find out the tangent vector for this point. What you need is the neighbor point. Let's say this one. What you need is the neighbor point positions for this point, which is this point and this point. And by calculating the directional vector value, you get 2 vectors, and by creating the average vector directing from this point to this point, you'll be able to get the tangent vector. Maybe I can show you that as well as a practice. Okay, if you just have one neighbors, then you can just use this vector as a reference. So for each point, you can get the neighbor points first by using neighbors. Like this, and then you use the for loop. Or in this case, you only have 1 or 2, so maybe still might be a good idea to create a create a neighbor, I mean the for loop. So let's say, although the direction is different, so yeah, I'm gonna still use the for loop. Maybe the process might not be generalized enough, but let's see how I'm gonna create these lines. Okay, so you get a curve points, you get a neighbor points, you can now get the position this. Right, and what I'm gonna do is to try to create a two values outside for loop. One is the starting point position, which you can start by at P. You also want to set the target point positions, which you can set it as at P as well. Right, so okay, when you have two points, that'll be easy. You can just say, okay, maybe I might need a conditions for this endpoint. Okay, if the current point number is less than the neighbor point, meaning the neighbor point is this point positions, then you can say the t-pos is equal to npos. If a pt num is larger than the npt, in this case, when you're looking at this point as a current point and this point is the neighbor point, then npt can be a as position. Now you can now create a vector going from the starting point position to target positions, which looks like tpos minus spos. You can normalize this, and then now this is not exactly the tangent vector, but this is more like a more modified one, because currently I'm not considering the lengths between the points, the neighbor points. You might also normalize these part as well, but the result you get is pretty much the same, I think. Let's check. So now I have just created a tangent u value. If I visualize this, looks pretty much the same. Although this is the other direction. If you want to create a tangent vector going from top to bottom, you just replace this with spos and this one to tpos. Alright, little bit of coding. So if you just want to simply get the tangent vector out of the node, you can just use this one. You can see that by changing the display value, this one keeps this visual, or this line direction keeps the same, so it seems like what I have done in terms of the calculation seems correct. Alright, so that's how you do it. Now that I have this tangent vector, I'm going to use this primitive wrangle to create a line from random points on top of the curve to start a new branch together with using these tangent vector. So let's name this create branch. Okay, so a little bit of coding here is necessary. First thing I like to do is to determine how many number of branches you want. Okay, so let's say the minimum number of branch is 1, and the maximum number of branch you'll set it randomly or by parameter. So max branch num. Let's say I want to create a branch from 1 to 4, something like that. And maybe I can parameterize this one as well. I can create another label, maybe together with the splitter or separator. Let's name this branching parameter. Then I can have this max branch number. Which is an integer value from 1 to 10. Alright. Now for each iteration, for each branch, I want to make this random value from 1 to max number. Sometimes, so if it's from 1 to 4, sometimes you get just single branch, sometimes you get 3 branches, and so on. So int rand or num branch is equal to random multiplied by, or using a fit function to change it from min branch to max branch. Since random function will create a value in between 0 to 1, and using a fit 0, 1, you'll be able to remap the random value into in between 1 to 4. Now for the seed, for the random functions, you do need a value that changes over the iteration for each iterations. So one thing you can use as a seed value is this iteration value from this detail attribute from this for each count. So let's get that value. Int iteration value is equal to detail from the second input called iteration. Okay, and another value that you can use to change the seed value is the number of primitive, which can be accessed by @primnum. And also, what else? That's pretty much it, I guess. And maybe you can add your custom seed value, which you can change by changing the slider values. So for that, I'm gonna create a seed value, seed channel, like this one. And maybe I can promote this as well. Let's call this seed from 0 to 10. Now, I'm going to create a seed first by multiplying iteration by some constant value. Could be any number. And I'm also going to multiply primnum by some another constant value, and then add it by this seed value. And this, by using this fit function, you'll be able to create a float value in between 1 to 4, but what I want is the integer. So in the end, I can say floor to delete the fractional value. Alright. Now that I get the numbers, I can now create a for loop using this num branch to create number of branches you want. Okay, let's open up the code editor. Okay, now next thing I would like to do is to choose the point position on top of this curve, which point is going to be used as the next branch starting point. Okay, so to do that, what I want to do is to get the point number which is in between 0 to, in this case, 49, because I have 50 points on top of this curve. Okay, so to do that, first I'm going to get all the point numbers out of this primitive by using prim points. Okay, now to determine the point position, I'm also would like to use another random value to choose point. Now I would like to create some simple rule here. It's a little bit complex maybe, but when you choose a number of points on top of the curve, if you just use a simple randomness, let's say you want 3 points on top of this curve as a starting point, the starting point for the branches. If you just use the random as it is, there is a chance that all those 3 points comes really close with some seed value. There's a chance that all these points comes close to each other in some direction. But what I want as a point position, even though it is random, won't have a separation between all these points. Okay, so that you'll be able to create a more spread, clean branches. Now, in order to create this kind of separation, what I first need is to divide the range for the randomness. If you have 3 branches, what you can do first is to split the curve into 3 ranges. This is going to be the first range, this is going to be the second range, and this is going to be the third range. And within these ranges you can create random points anywhere. So within the first range you can, let's say you can create a random point position right here. In this case you can create here, here, right here. So by doing like this, you'll be able to separate the point as much as possible. I mean, there is a chance that the point created pretty close to each other for a 2 point, but at least for the third point you can separate the point distance. Okay, so this is what I would like to do within a Vex. Let's think how we can do this. Alright, so first I am going to create a range value, which is going to be the minimum to maximum. In this case, in order to create those point position, first you do need to understand that the curve position can be determined by the normalized value. Let's say the overall curve can be expressed by 0 to 1 in terms of the address of the point position. So let's say the starting point can called 0 and endpoint can called 1. Okay. Now when you want to divide the range into 3, you can set this point position 0.333, this point 0.666, and this random point position that you want to create in on top of this first range, you can create a random value in between 0 to 0.333. Okay, so if it's 1.515 or something like that, then the point will be always inside within this range. For the second range, you want to create a random value in between 0.333 to 0.666. And for the last one, you want to create 0.666 to 1.0. So by changing the range for each random value, you'll be able to separate the point position. Okay, and that's what I am going to do here. So first of all, I'm going to divide the 1 by the number of branch. So if the number of branches is equal to 3, then you get 0.33333. Oops. And that is going to be the basic range amount. Okay, and for each loop, you want to create a minimum range to maximum range. The goal, the starting value for the range, and the goal value for the range. So let's say S range, the starting range is going to be the range amount multiplied by I, and the target range is range amount multiplied by I plus 1. So when the I is equal to 0, this value becomes 0. When the I is equal to 0, then this value is going to be 0.333 when the branch is equal to 3. And when the I equals to 1, then this becomes 0.333 and this becomes 0.666. Okay. Now that I have those branches, I can use these to create a random value again. So let's just call it value, and I'm going to use another random function, random value. Now I can pretty much use the similar seed value like I did previously. In addition to these ones, I can use this I value for the additional seed value. So let's copy these, change the constant number to something else, then add additional seed value, which is I multiplied by some other constant value. Right. Then this random value is currently in between 0 to 1, so I can change this to S range to T range by saying fit 0, 1 value in to S range to T range, just like this. Okay, now after this, you'll be able to create the value for each range with the number of branches, and then you do need to change this value into the point number. So the last value you get is the point number, which is in between 0 to 50, which can be determined by getting the length of the PTS coming from this print points, multiplied by value, and get the floor value. And then or I can just say pt index. And the actual point number you want to get from this prim points is actually the pts pt index. And this is the final point number which you have just picked from this curve. And then for those points, I am going to set the group to indicate that these are the point to start the branch. So I'm going to say set point group branch with 1. Okay, now after doing all these process, I can now remove the last group from this whole primitive. So let's say set prim group last two primitive number to 0. It's like this. Okay, just a bit of long code, but I think it works. Alright, do I have any other parameters? No, I don't think so. Okay, let's check if the branch point has been created in a correct manner. I can check it by creating the color node. Only works on the point with a specific group, in this case a branch. And let's set the color to like red. Let's see if I have any red point anywhere. I don't see it because I haven't visualized yet. Okay, so now currently I have one single group, single branch point right here. Let's see if I can change the number of points by changing the seed value right here. I change this one. Okay, I can see that sometimes I get 2 points, sometimes I get 3 points, so on. Right, so I think it's working. I can see that it doesn't go over 3, even though I say the maximum branch is equal to 4. Maybe I need to change a little bit of coding. I think I cannot use floor, but instead I might need to say I might need to say max branch plus 1 to get the maximum number for the branches. Okay, now I can get 4 branches as a maximum number. Right, looks good. And each point is separated in a nice distance. Okay, another question. Can I send you some questions later during the week on some concepts I think people in Houdini will be interested in, and maybe include them in your next stream if you haven't got a topic as yet? Yeah, you can write the comment onto this video to the live stream after it has finished, and then I can look at it and see if I can answer it for sure. Okay, now the check is over. I don't need the color node. The next thing I'd like to do is to actually create a new branch. I mean, I can just do it within the same node, but the code is going to be really long. So let's do it in other point wrangle. So in this case, maybe create branch is the wrong name. This can be set branch position. Okay, now the next wrangle is going to be the wrangle to actually create the new branch. So I'm going to for this one, I'm going to use the point wrangle, name it as create branch, and filter the group to branch. Right. And get another iteration value here. To create the actual branch using another code. Maybe I can connect this here. Okay, so let's see what I can do here. First, I can get the iteration value, which I can later on use as another seed value for the randomness, or maybe for a noise function. What else? I can also... Okay, so first thing I would like to get is the tangent vector value, which is going to be the direction to create a line. Okay, so let's call that direction, which is previously it was going downward. So let's create a negative value, the negative value for the tangent vector, which is tangent u. Okay. Now in this direction, I'd like to create a line, and first thing I'd like to do is to set the length of this line. So float curve length is equal to, I can make it from the parameter, so, or maybe this initial curve start the length from 1, so maybe you don't want to create the length over 1, or maybe I can create a value to scale down or scale up the length, the initial length value, to make it larger or to make it smaller or to keep the same length. So let's say length multiplier. I'm going to create a parameter called length multiplier. Oops. Promote this, which is going to be from 0 to maybe 2. If you make it from 0 to 1, you can make it smaller. If you make it from 1 to 2, you can make the line larger. Okay, now let's also bring this to the controller node as well. Branch length multiplier for each iteration. Okay, now in order to create the lines, I do need another 50 points, okay, which I have used right here. Okay, so maybe this point, this number of points also might need to be parameterized. So let's drag this point number to init curve section and say number of points from 0 to 100. So by doing it, you'll be able to pass this parameter to another node. Let's bring up this value. numpts is equal to and let's paste this, link this value so that I can use the same value, same point number value to create to create a new line. Now, having this point number, I can now create a for loop so that I can create, for each line I can create 50 points. I'm gonna loop for 50 times, and in specific direction I'm gonna create a array of points. Okay, so the direction is going to be this direction. The number of points that I'm going to create is this point number. And I also have the lengths by multiplying 1 by this length mult. Okay, so let's change the lengths. Let's get the final length for each iteration first. The curve length can be calculated. Maybe I can calculate this outside the loop. The curve length can be calculated by changing or using the power function for the length mult ratio with the iteration. This means that when the iteration is equal to 0, which is coming from this one, when it's equal to 0, the multiplier becomes 1, even though I have set to 0.755 for now. This becomes 0 for the first iteration. Now when the iteration value becomes 1, which means the second recursive process, this value becomes this value. And on the third iteration, when the iteration value is equal to 2, then what you get is the length multiplier multiplied by the same length multiplier, meaning 0.7555 multiplied by 0.7555, which makes the overall value smaller. Okay, and as a result, the overall length becomes smaller. So for each iterations, the length becomes smaller and smaller when the length multiplier is less than 1. But when it gets more than 1, then the length of the curve becomes larger and larger by using this power node power function. Okay. Now that I have all the necessary information, I think I'm ready to create a list of points to create the curve, to create a line. So int new point is equal to add point, and I also need the new point position. New positions is equal to starting from the current point position, which is at P, and to the direction I can multiply it by the I divided by the curve length, the I divided by the number of points minus 1. This is the normalized value from 0 to 1. And then I can multiply by the length of the curve. And then add a new point to this point position. Now I can see that the new point has been added in a specific direction, which is tangent vector direction with number of points. Okay, looks good. And if I change this value, okay, seems like it's not changing the length because this is at the first iterations. Maybe it makes sense that the length becomes smaller in the first direction, so I can make the iteration added by 1. Alright. Now I can control the lengths, I can control the number of points. And the next thing I would like to control is the randomness going in the plane direction of this curve, just like I did for the first init curve to make it curvy curve. Alright, to do that I need to do pretty much the same things that I did in this initial curve right here, creating a noise function to determine the noise direction, random direction, move it by this directional value, and so on. Right. So let's do this. But first, let's try to connect all these points as a primitive so that this becomes a polyline. You can do that by creating a add prim outside the for loop and called add vertex with for this polyline with this npt. Alright, this just works. Okay, now let's try to change the curveness or the point position to make it curvy for this line. What I need to do is to change the point position for this newly created point. So let's do this by first of all going back to the initial curve, and maybe I can refer to those functions. I'm going to copy all these, or maybe I'm just gonna copy the first line from the initial curve, going back to the create branch, paste it somewhere right here, and let's say I'm gonna name this branch direction. Okay, so let's promote the smooth and shift, which I think I can just refer to the same value which I have set right here. So I'm gonna copy the smoothness, paste it right here, do the same for the shift, rename this to shift. Okay, now the thing that I need to do here is to set the y direction for this value that I've created to 0, but in this case the y direction is this direction, this vector direction. Currently the for the initial curve this was pretty simple because it was going upward, so that you just needed to make the y value to 0. But when it's directing to some random directions, you cannot just do something like this, because it's no longer going into the y direction. But instead, you do need to calculate a little bit of dot product to determine what value must be reset to 0. Okay, so you do need to have a little bit of linear algebra right here to determine what kind of value must be subtracted from this direction. So let's think it in a sketch to see what kind of value that I need to create in terms of the vector. Okay, seems like I need a lot of calculations for this. Okay, so let's say I have the lines like this, and let's say I am looking at this point right here, and I have just created the random direction using the noise function, which goes in this direction. But what I actually need is a perpendicular direction going this way. So what I need to do is to project this curve to this perpendicular line or perpendicular plane. Okay. So let's think how I can project this curve, this direction to this line. And to do that, the information that I have currently is this line direction and this red vector value. So first, by having these two information, what I can get is this projected curve or projected direction in a line direction. Let's say this is the vector 1 and this is the vector 2, or maybe the capital V. This is the small v1, and let's say the projected vector is v2. Now in order to get the v2, what you need to do is to first get the dot product between the capital V and v1, which you will get the length of this value. Okay, let's just call this L. Now after you get this L, what you just need to do is to multiply this dot product with this V. And then you'll get this V2. Simple enough. Now after you have got this tangent vector or parallel vector value, you can now subtract this original v1 with this v2, and as a result you get v3, which is the perpendicular vector value. And that's the final vector that you want to get. Okay, looks simple, but a little confusing. So let's do this. First I can calculate the lengths using a dot product between the tangent vector of the curve I'm not sure if I have this tangent vector value. Okay, I think this is correct. Maybe I can just use the direction. Yep. And then what was the next one? Yeah, this one, the vector value that I've just created. Now I probably could make this normalized. Yeah, normalized. Does that make sense? No, maybe I don't really need to normalize this because I just need to get the direction. So doing like this, you'll be able to get the lengths. Now in order to get the perpendicular directions, you can multiply direction by L. Okay, and then what you want to do is to subtract b direction by this direction multiplied by L, and you get the final direction where you want to move the point. Okay, and you can finally update the point position by adding this directional value. Oops. I think it is moving to the perpendicular directions, but it's moving. Everything is moving at the same value. Now let's see why. I do have this smoothness. Doesn't seem like this thing is changing. Oops. Seems like it's not affecting the value, so maybe something is wrong with the calculation. Okay, I have at P, smoothness, shift. I probably need a additional seed value for this one because I have a bunch of points right here, and I don't think I can use at P for this one because this is going to be just a single value. Okay, so instead of at P, I'm going to use I instead, or maybe npos instead. Alright, then I can add additional value here, which will be maybe ptnum multiplied by some constant value, and let's see how it goes. Okay, now it created a curvy curve which I wanted, although the starting point also shifted to some random direction, so I do need to make this go back to the branching position. Okay, so to do that I do need to know the starting point positions, then later on I can move this back to the original position. Okay, so to do that, let's create a position called start pos outside the loop, and this position can be retrieved when I is equal to 0 after moving this direction. So if I is equal to 0, then set the start position to npos, and then I can move the end position for all the iteration, all the loop iteration with this start position to make an offset. Oops, I think I did something wrong. I do need to say start position minus at P, current point position for the branch. Alright, now it fit. Okay, looks good, and the curvature, I mean the tangent, looks smooth enough for the connection. Okay, let's try changing those values to see how it changes. Yeah, looking good. Alright, that looks good enough. Maybe another thing I could control is how much it shifts in perpendicular direction by creating another scale value for this offset, which can be multiplied somewhere around here. If you want to have that, then you can have another parameters called offset mult. And doing the similar calculations like this one, you can say float offset is equal to power of offset mult iteration mult plus 1, promote this offset multiplication value. Let's start from 1. And what I'm going to do is to multiply this offset value to this f direction, and by making this smaller, the offset to perpendicular directions becomes smaller and smaller for each iterations. Okay, let's promote this value to the parameter set as well. So offset mult branch offset multiplier from 0 to 2 again. Okay, I think this is pretty much it. And after creating this branch, I no longer need this branch group anymore, so let's set the branch group to 0, set point group 0, branch at ptnum to 0. Okay, and after I have created this primitive, I do need to set the last group, so set prim group last prim num to 1. Okay, I think I have enough information here. What else do I need? Maybe this is it. And if I leave the loop and raise up, okay, I think something is wrong. It still keep creating the branch at the same single branch, even if I raise up the iterations. Okay, something is wrong. Okay, let's see. Okay, first of all, I need to make this polyline. Okay, is this working? Let's see if I change. Okay, seems like at the last iterations the tangent vector seems a bit wrong here. The direction for the next branch seems a bit wrong somehow, doesn't it? Or maybe is it correct? I'm gonna check it by setting the offset mult to 0. Okay, maybe this is correct. It's just shifting too much. So maybe I can make this 0.8. Alright, looks good enough probably. Now let me check how this is going to create the variation. Okay, looks good enough. Seems like there's a lot of points created here. Okay, I think I like the result. Okay, I think that's good enough. All right. Okay, let's see. I have a comment. What is the advantage of this method compared to using L-system? Well, if you use L-system, I think you need to know how you can write the rules in characters, which for me looks a bit too complex. I don't know, I'm not really fond of this L-system, but when you need to write the rules, you need to write like this, which looks a bit too confusing to me. It's not too straightforward to me in order to create the geometry that I want as a final result. So I mean, for maybe if you know how to write the rules for this recursive or L system, I think this still is a good idea. But for me, it's too hard to write these rules. I cannot really imagine what these rules will create as a final result, so might not be a good idea for myself. I mean, there might be a more better way to control this L system, because I see a lot of people using L system to create a custom geometry with their needs, so maybe there's a way. But for myself, I don't really know how I can do this, how I can use this. So I always create my custom function for a recursive stuff like these. You could probably create similar things using L system. I just don't know how. In order to create a flexible detail control. Okay, now that I have this curve in control, what I want to do next is to create a geometry out of this curve, which what I'm going to use is some a BDV function to do this. Let me see, let me find out the best position for the curve. See if I can get, okay, this looks nice. Okay, I think I also need to control the iteration value right here, how many branch iterations I want. This looks really wild. Okay, so let's also promote this number to the node controller. Going back, drag and drop. Gonna have to check off this value. Branch iteration from 0 to 5. Okay. So let's see. In order to create a branch from this, the geometry from this curve, what I'm gonna use is the VDB from particles to create a spherical geometry on top of this curve. And to use this, I think it's a good idea to set the P scale to each point as well, which I haven't done yet. So let's do that. The initial point radius can be really small, maybe 0.15 or something. And I also need to make this voxel size smaller. Now this might be too large. Okay, I'm not sure. Seems like... Okay, so for the newly created branches, the P scale value is set to 0, so nothing appears here. So let's try to set the P scale to the points. Let's go back to the point where I create the branch points somewhere around here. I can also set, what I can set as an additional value is the P scale attribute. So let's do this. Maybe for the P scale, maybe I can imagine that the branch thickness also becomes smaller and smaller for each iteration, so I can have another parameter here, P scale mult. Just like the other offset and lengths. Make this, let's say 0.8 or something, and then create the actual P scale value, which is power P scale mult iteration +1. Okay, now I can say set point attrib P scale to the newly created point with P scale. Okay, now I seem to have a branch shape appeared as a pipe shape. Maybe a bit too thick. I can make this reduced. Okay, starting to have a little bit better shape. Okay, let's go with these. Doesn't really matter what the final result is for now. Okay, let's have this promoted to parameter list again. Going back. Drag and drop this P scale multiplier. Alright. Okay. Now after I have created the VDB like these, if you want I can also smoothen out a little bit using VDB smooths to remove the edges right here. Create it more like a coral-like shape in the sea, inside the sea. Okay, looks nice. Maybe I can raise up the initial. Probably I could parameterize these values as well, the initial radius. Okay, maybe I can separate to create a new parameter branches. First of all, the point scale. thickness or radius. Let's also create the label to explain what these are. I don't know, branch, mesh. So in those cases, maybe I can bring this p scale to right here as well. Okay, for the radius, I can say this is in between 0 to 1, maybe 0 to 0.5. Right, looks good. And after seeing those geometry, if you think these are good enough, I can then convert this to mesh by saying convert VDV. The next main step is to create a hexagonal or heptagonal, or those polygonal shape on top of this geometry. Then use it as a path to run the vein-like trail from bottom to top. Okay, so I've just converted the VDV to polygon. Doesn't really matter about the quality, but for now looks good enough. Okay, now in order to create a polygonal shape or polygonal divisional shape, I am going to use the remesh node to limit the number of points first. This might be too sparse. Maybe this parameter can be parameterized as well. I can drag and drop this target size, or let's name this remesh length. Let's say 0.005. I think it's a good value to start. And what I want to do next is to raise up this iteration a little bit more so that I have more regular size triangles all over the place. Okay, looks good. Now, in order to create a polygonal shape out of this triangulated geometry, you can just use the divide node and then use compute dual. You'll be able to create this kind of hexagonal, heptagonal, octagonal shape all over the places. And this is done by creating in between polygon and between lines to each connections of this triangle shape. Okay, this already looks pretty nice, but the final step that I want to do from this one is to create a animated trail going on top of this edges from bottom to top. Okay, and that's the final thing that I want to do. So to do that, first thing I like to do is to retrieve only the curve geometry, only the curve information out of this geometry. So first I'm going to convert this into line by using convert line node. As a result, you'll be able to get the curve like these. And then I'm gonna make these curve as a smoothed curve. So I'm gonna create the resample node, checking the resample by polygon edge so that the edge point, which is these connecting points, will be preserved, and you'll be able to get the number of points in between these points. Now I'm going to disable this maximum segment length, but instead I'm going to check this maximum segments, determine how many points I want inside this edges. Let's say I want to have 5. Okay, the reason why I want to create a bunch of points like these to each edges is because later on I want to project this curve on top of the mesh. So I want to make these edges a bit smoothen out so that I'll be able to create an arc-like shape. Okay, so after resample, I think it is a good idea to use the fuse. So the number of points will be reduced. Okay. So these are the initial setup for the curves. The next thing I like to do is to set up the animation from bottom to top. So to do that, what I'm gonna use is a function call, or the node called find shortest path. And I'm gonna use this node to determine the path going from bottom to top, where the animation goes through this network. Okay, so to do that, I am going to, maybe I can use this to these curves instead of doing onto this mesh. Maybe that's easier. Now in order to use this find shortest path, you need to set the start points and the end points. So let's create that first. For the start points, I can go back to this one, and let's say the start points is some points somewhere around here. Maybe I can just use the single points somewhere around here. Maybe a point which is at the bottom point position. I can pick a single point somewhere around here, or maybe multiple points as a candidate. Now let's see. Maybe I can say the y value, the y coordinate of the points, which is less than 0, can be a coordinate for the starting point position. So point wrangle, I'm going to use the point wrangle to set the start point position. If at p.y is less than 0, then set point group to set point group, the name of the group is going to be start to each of the point with 1. Okay. Now I also need to set the end group, which is going to be the goal point. Probably those points can be somewhere above the branches, around here, In order to indicate those points, I'm going to use a scatter points with the density. Okay, and I'm going to set the density for the upward higher and the lower part lower, I mean smaller. So to do that, I'm going for each point, I'm going to set the density value based on the height value. And to do that, I think it's a good idea to get the maximum value for the height. First, I'm going to get the maximum value for the bounding box using get bboxmax. Now I can calculate the density value by, first of all, normalize the at p dot y based on the max y, so the value becomes 0 to 1. Now I can then use the power function with some parameter to control the linearity of the density. How much points is going to be gathered upward. Then set it as point attribute. Okay, and based on this density attribute, I can now use a scatter node to create a bunch of points on top of the curve. And I'm going to use this density attributes, which is currently not working as I suspected. Let's see why. Because I haven't created any value for this one. Okay, let's set it to 1. Okay, now I can see that the point has been gathered in above direction. Maybe I can raise up this a little bit more to control how much points it's been gathered upward. Maybe I can say between 1.5 to 2, maybe 2, like this. So a lot of points goes upward. And I can see that the point number is a bit too much. So let's reduce the number, and these number can also be parameterized. So let's see. Going for these one, I'm gonna set the label to vein. So where's the label? The label. I'm gonna name this vein. And first of all, let's bring this number of points, which is the end pt num. Okay, I can also promote this density power for the endpoint. So end density power. Which is from, I don't know, 0 to 2. For the point number, maybe the maximum can be 1000. That might be too much. Okay. So let's go back to the controller to maybe 1.5 is good enough. Okay, now that I have two set of points, for those newly created points, maybe I can set another point group. Although I do need to set the point group to this geometry, not to the scatter point. So what I'm gonna do next is to refer to this geometry refer to this scatter point and get the nearest point number. What's the best way to do this? What's the best way to link it? What I want to do is to get the nearest point position. Then get the current point position on the self. So gotta do the new point 2 times, I guess. Then set point group as target or goal. To have endpoint, maybe I can say end. Okay, now I have 2 set of groups. One is the start, one is the end. Let's check start and end. Okay, I don't see end. Okay, there you go. I can now use the find shortest path. Going from start to end. Now, the setup here is going to be from each start to each end, which will create a bunch of network. Now that might be too much because it's using all the it's creating all the possible connections from each of the starting point to each of the end. Maybe after all, picking up all the starting point under 0 might not be a good idea. Maybe just picking up a single point might be a good idea because currently there's too much branches. So let's change this one to say, okay, let's also get the minimum value from the get bounding box. Get bound box. And I'm going to say if at p is close enough to the min y, then I'm gonna pick it to start. To determine if it's close enough, I'm going to calculate the differences together with the absolute function, like this. Okay, now I think the single point is going to be used and the number of branches will be reduced drastically. So this is going to be the pass for the animation. Let's say from any start to each end. Okay, that'll do the job. If you want to raise up the number of paths for the animation, you can just raise up this endpoint number as much as you like. Okay, so the path has been created. It's time to actually create the animation on top of this curve. Okay, let's do this. What I am going to do is to trim out the curve. Let me test it with the single primitive. I'm going to pick this first primitive. And what I'm going to do is to, based on the timeline, based on the frame value, I'm going to trim out the curve at some range going from bottom to top. Okay. Now, what I'm going to do is simulate it by using the carve. function. It's similar to controlling those u and v value to trim out the curve, but I cannot really use carve because I cannot use attributes to these parameters. I mean, if you do it in for each loop, you can actually do it, but that's going to be really pretty slow. So instead of using the for loop, I'm going to control these value all in vex, trying to recreate this carve inside of vex from scratch with the animated attributes. Okay, so let's do this. I'm going to use the primitive wrangle for those, and I think that is going to be the heavyweight vex code for this tutorial, and it's already been 2 hours. I'm not sure if people are still here. If people still want to hear about this one, maybe I can create this in next week or something if people get tired. If not, I can continue because I've already been creating these. Okay, I think I still have people listening, so let me try to continue. So I'm gonna name this trail animation. Right, so let's do this. I'm gonna test out with this single primitive so that it's easier to see what's going to happen here. Now, let's open up the code and see. Let's think what I need to do here. First of all, I do need to create a frame-based value to determine the movement, but let's think in Sketch first. Okay. So when I have this pass created from the shortest pass, what I want to do is to trim out the curve at specific range based on the distance, based on the frame, and this pass will move to this direction. By shifting the endpoint. And to do that, I need to specify the point position of this curve. Let's say this is U1, this is U2. And also, since I want to make it as an animation, I will need to link this with a frame value. Frame 1 and frame 2. And I also need to consider what's the length between U2 and U1. And also what's the frame differences between U1 and U2. Okay. And for the parameter, the parameter I could set is probably this length, so that I can determine how much the trail length will be. Okay, so let's say that I can control this length in between U1 and U2, and also the speed by changing the F1 and F2. And see how I can control this trail. by writing the code. Okay, so first of all, I'm going to set the length, target length. I gotta write it here. Float target length is equal to length. Let's start by 1. And let's also promote this to the controller build control node by drag and drop. I'm gonna name this vein length. Okay. 1 might be too much because this is close to 1. So make this smaller, like 0.1. Alright. Now I'm also going to parameterize how many frames I need to go from the start point to the end point. Determine what's the speed of the trail. So I'm gonna name this total frame by creating total frame at parameter. This is going to be integer, but yeah, integer. And this value depends on the frame you're using. Currently I'm using from 1 to 240, which is about 10 seconds. So let's say I want to use the half or 100 frames to finish animating from the first point to end point. Okay, which is about how many seconds? 5 seconds and so on. 4 to 5 seconds. Let's set the range to in between 0 to 200. Let's also promote this. Main total frame. Main animation total frame. Okay. Now, there might be a chance that you want to offset when to start animation, when to start animate. I mean, sometimes it's good to start the animation from the first frame, but maybe in order to make more organic in terms of the animation, sometimes you want to start the animation from like 86 or from 128 and so on. After leaving some frames blank, starting the animation from somewhere in between this frame. So you might also want to have this offset frame value as well. So let's have that value. Offset, or offset frame is equal to CHI offset frame, and this is going to be the maximum offset frame. I can also use together with the random value. I can try to control. I can try to create the various offset frames using this as a maximum value. Okay, let's make this one as 100 as well. So the animation will start somewhere in between from frame 1 to 100. Okay. And I also want to promote this as well. Drag and drop. a vein animation offset frame from 0 to 100 or 200. Okay. Okay, I think I have enough parameters. Let's try to create some stuff, some calculations. Now, first thing I would like to do is to actually calculate the random offset value out of this maximum offset frame value. So I think it might be a good idea to make it as a float to make as a smooth animation. So I'm gonna make this as a float offset value starting from random based on the primitive point position, or maybe a primnum is primnum multiplied by some constant value plus some seed to shift the value. Now the seed can be brought from this one if you want, if you're okay by changing the branches at the same time, or if you want to control the seed value randomly, then you might want to make this separated. Maybe creating separate seed value makes sense. So I'm gonna drag and drop this one. And between 0 to 10. Okay. Now that I have this random value, which is currently in between 0 to 1, I can remap this in between 1 to offset frame. So just like this. Right, now and this offset frame is going to be used as a starting frame, okay, where the animation starts. So let's rename this int start frame is equal to offset. Now let's also create a end frame as well. When does this animation is trimmed? If it starts from here and you also want to determine the end frame as well. When does this end? Okay, and that can be calculated by adding a start frame together with the end frame or total frame right here. Okay, maybe after all, I think it's a good idea to make it as a integer offset. And, oh wait a minute, this should be float because this is randomness. Okay. Yeah, I think this is good. I think I can just say floor offset this start frame. Okay, so now that I have start frame and an end frame, next thing I like to do, next thing I need to have is the actual frame value for the animation, the current. So for the trail, I have the head position and the tail position for the trail, for the vein. And I do need the frame value for the head and frame value for the tail. So, and the head, the frame value for the head is actually the current frame value. In this case, 60. So that's straightforward. The head frame is equal to at frame. Now for the tail, in order to calculate the tail frame, you do need to use the length of the curve. And from the length of the curve, you need to calculate how much frame you offset from head to tail. Now in order to get the length of the curve, currently I don't have the information of this length, the total length of this curve, so let's create that by using the measure node right before the tail animation node with the parameter option, so that you'll be able to get the length of the curve at the primitive attribute like this. Okay, and using the total length of this curve together with the tail length, which is this one you set manually by yourself, you'll be able to get the ratio, how much ratio is used within this curve with this length. If it's 0.1, then, which is about, how much is it? 5% of this curve. So, going back, int tail frame is equal to, first of all, let's calculate let's normalize the length value in between 0 to 1. So the length, target length divided by the parameter, you'll be able to get you'll be able to normalize the length in between 0 to 1, which is going to be, which can be used as a percentage of the length. Then you can multiply it, spell mistake, you can multiply it by a total frame, which is the total animation frame for this curve, and as a result you get the total frame for the vane, meaning you are multiplying some percentage to the total frame, you get the same percentage. You are using the same percentage for the length of the vane, and then as a result you get the total, you get the frame value for this vane. And for since this is a tail, you want to subtract from the current frame, and as a result you get the tail frame. Okay, now that I have this frame for the head and tail, I can now convert this in, I can now normalize this again, which these values in between start frame to end frame. So I can use the fit function to create the value in between 0 to 1. So float f head is equal to fit. So head frame is in between start frame to end frame, and I want to remap in between 0 to 1. The reason why I'm remapping to 0 to 1 is because it's going to be useful in order to use it for a UV value to determine the position on top of the curve. F tail is fit tail frame, start frame, in between start frame to end frame, like this. Okay. Now that I have the U value for the head somewhere around here, and tail value for the tail somewhere around here, U value for the tail somewhere around here. So using these two U value, I can determine the position for those two curve on top of the 2 points on top of the curve. Then after I get those value, I can then trim out the curve based on those information. Let's see how I can do that. Now, let's first get the point position for this head and tail. Vector position tail, or tail pos is equal to I'm gonna use prim UV in order to determine the point position on top of the curve using this head value or tail value as a U value. Okay, so prim UV, gonna get the P position at prim num, and I'm gonna create the UV value by setting the F tail for the X value, and rest of the value will going to be 0 because we're dealing with the curve. We only have U value to determine the position. Now that's for the tail. Let's do for the head as well. Just change this to head. Okay. Now I might also need a additional value to get the point number on top of this primitive, which is going to be a PT num, but unfortunately you cannot retrieve the point number using prim UV. So instead I'm going to create those point number as an attribute previously using something like point wrangle, so that I can also get those point number using prim UV as well. The reason I'm trying to get the point number is because I do need those information to recreate the primitive, which looks like trimmed out curve. So let's call this ID, and I'm for the convenience I'm gonna create the attribute as float. So float ID is equal to at ptnum. Okay, so as a result, if you go to the point number, you get an ID attribute, which is the float number, copying those point number as a float to this ID. Okay, looks good. Going back, let's get those ID value for head and tail as a float. So tail ID is equal to, I'm gonna use the same prim UV, looking at the ID attribute, and do the same for the head. Head ID, like this. Alright. Now I think I have enough information. Let's try to trim out the curve based on those information. And to do that, I'm going to create a for loop which is in between tail ID to head ID. And in between those IDs, I'm going to copy the points from the primitive and recreate those points as a new primitive. So initially I'm going to create a new primitive as a new trimmed out curve. When I say trimmed out, I am not going to reuse the current primitive, but instead I'm going to recreate a new one, and after we create a new one, I'm going to remove this original geometry because that's more easier to create a custom geometry. Removing points is sometimes a bit too difficult to control, especially when you want to add the new points on the end for polyline. So that's the method that I'm going to use. So I'm going to create a new primitive as a polyline, and you create the for loop starting from tail ID. Okay, tail ID, and since this is a float value, I am going to make it as a ceiling. Now, I guess I need to explain what I'm going to do next in Sketch. Okay, so let's say I'm acting on this curve, and what I have just done, let's say there is a point somewhere around here, okay, creating a polyline for this original geometry. And what I have done here, based on the frame, current frame, I have picked up the U value, or point position value, which is in between this curve. Let's say this is the head position, and this is the tail position. And as you can see, this point is not on top of this control points of this original geometry, but you do need to create additional points right here to trim out the curve, right? Considering that, the attribute or the information that I have right now is this position information, which is the tail position and position of this head position, head point. And also I have this ID value for head and tail. And this ID indicates the point number, which is this point number. And since I have made it as a float value, this value can be retrieved as a float, which is currently in between 3 and 4, so this can be somewhere like 3.5, and since this value is in between 6 to 7, this ID can be maybe this can be like 6.4 or something like that. So having these float value, I am right now trying to create copy these points within this ID 3.5, in between 3.5 to 4.6. Okay, so the ceiling number of 3.5 is 4, and the float value of this 6.4 is 6. So in between 4 to 6, I want to copy these points as a part of the polyline. And I also need to pick this point as a starting point position and the end point position. So in total, you have this starting point, which is the tail point position, and head point position, which is the end point of this polyline, the trimmed polyline, as well as the inner point positions. And by connecting all those points together, you'll be able to create a trimmed out curve. And after you have that, you can then remove the original primitive. And there you go, you get the trimmed out curve. That's how I'm going to make this carved curve. So from ceiling of the tail ID to a floor of head ID, I can get the position using this I value as an ID. This can be used as a point number, actually a point number, to retrieve the point position in between the tail position and the head position. And then I can add this as a vertex to this polyline primitive. Okay, I need to add it as a new point, so npt is equal to add point 0 position, and make it as a part of the primitive, like this. Okay, think it's working. Yeah, and let's try to remove the original geometry. To see if the geometry has been trimmed. And you can see that if I change the frame, it is changing where the geometry has been trimmed. Now, as I said, I also need to trim out the curve based on, I also need to add this tail position and the head position as well to make the more precise curve. So the tail position is going to be used as the starting point of the primitive. So this goes here. And to do that, I do need to add the tail position as a point. So tpt is equal to add point tail pos at vertex 0 prim tpt. And at the end point after the for loop, head point is equal to add point 0 head position at vertex 0 prim hpt. Okay, so let's check this out. Showing up the original primitive, and since currently the primitive has been resampled, so it has a bunch of points in between, so it might not be straightforward to check. So I'm going to make the segment to 1 for now, so that it's just going to be a simple straight polyline. Now let's go back here and see if it's working correctly. Now the original geometry is this one, and you can see that it is creating a in-between points right here, in between this point and this point right here, and this point is also being created in between this point and this point. And by changing this frame, you can see that this point is shifting on top of the curve like this, and I think it is working as I suspected. And if you raise up the lengths, currently it's 0.0, I mean 0.1. If you raise this to 0.5, you can make the length of the curve larger. Makes the trail larger, like this. Starting from 0, creating animation. Yeah, I think it's working. And nicely animated. If you play it, yeah, I think it's working just fine. And since this is a primitive wrangle and currently I'm just testing with the single geometry, but if I disable this one, I can now see all those curves being animated. Everything is shifted based on the randomness. And I can change the shift value here. If I want all those frames to travel faster, I can make this 50 to make it faster. Or if you want to make it slower, you can say 200, using 200 frames to travel from start to end. If you want to have more offset in between those curves, you can say 200 to these, so that the timing of each curve to travel becomes more, I don't know, sparse, so on. Okay, hope it makes sense. So let's make this back to 100. Okay, so in terms of the animation, looks good enough. Now let's make the resample back to 5 to make it a bit more, have more points, and see if it still works. Yep, fast enough. Yep. Now the next thing I would like to have is the value applied to each of the point from head to tail, some resampled or some normalized value from 0 to 1 from tail to head, so that I can use it for coloring, like white to red and something like that, a gradational color, which is going to be pretty easy to set. So let's do that inside the loop. Right after I created the point, I can say maybe somewhere around here I can create those value based on the I value here. So float value is equal to I fit. I is in between sail tail head tail ID to floor head ID, and I want to remap this in between 0 to 1. Okay, and that's pretty much it, I guess. Set point attriv. Just gonna make this as a value attribute, which is as a general value. npt val. Okay, so for the TPT, I also need to do the same things for the TPT and HPT. Oops. This has to be NPT. So the tail point, I'm going to set the value as 0. Set point attriv. Val TPT 0. Set point attriv. val for a head PT. I'm gonna set it as 1. And that will, I think that will do the job. Let's test it out. I'm gonna use the color node. Well, what happened? Color node with the point ramp from attribute, looking at the value node, and see if I can create the gradational value. Let's say from 0, from white to red. Nope, it's not. I think I did something wrong here. Let's see what. Everything is 0, except for the first one. Okay, I guess the fit function didn't really work. Okay, so this seems like it's not working. Okay, I is in between tail ID to floor ID. Huh, looks correct to me. I might need to make this one floor. Nope. Let's see. Let me see what's wrong here. So this is the point number that I have added, and I'm setting this value here. Huh. Doesn't seem correct, does it? If I set the 0.5, does it gives you a 0.5 attribute? Nope. Okay. Something must be wrong. Set point attrib. Okay, let me just copy these. I'm going to need to set the attribute to npt 0.5. Still not. Huh. Okay. Why? Why is this? Why is not working? Do I need to say before at vertex? I don't think so. I don't think so. This is weird. Let's see. Let's see if I create another attribute, something like AAA. See if I can get... Okay, now I see it. Weird. Okay, now I see why. Because this is because Houdini thought that value is an integer when I set this 0 right here. I had to say 0.0 here so that I can Houdini can understand that this is a float number. Because it was determined as an integer, it just may convert this value into integer value. Same for this one, gotta say 1.0. So there you go. There you go. Okay, seems like this first value becomes 0. This last one becomes 1. It's not really ideal. So for the first one and the end one, I don't want to make it as a 0 to 1, but instead, how do I make it? I can say this is CL -1 at +1. Okay, there you go. Clean range from 0 to 1. And there you go, you'll be able to create more gradational color. I have a comment. If to use shortest path vex function, is it possible to do everything in one wrangle together with the tail? Yeah, yes, you can do that for sure. Instead of this find shortest path, you can use the what was the name called? Let me look at the vex function page. There is no find shortest path, but instead you can use the what was the name called? Surface distance. This one. This surface distance will give you a similar result with the shortest path, which can calculate the shortest distance between the point to the end. And by using this information, you might be able to get the path, but not too straightforward, I guess. Now that I think, you might need to combine this surface distance together with all those necessary informations, because this doesn't give you the path itself, it just gives you the distance. So you do need to use this information together with another information. What would that be? I mean, I think you need to check all the neighbor points to find out the shortest path. So I think it's not too straightforward, not that easy to do inside of X. So just for your information, using find shortest path is much easier in this case. Okay, so not going to try that because I think it's going to take too much time for me to implement that. Okay, now I have this gradational color value. Let's show up all those curves together. See how it looks like. Okay, nicely done. Now what I want to do next is, I mean, I can just place this on top of this geometry or the curve, merge it together with those geometries. With some animations. And since this is on top of this geometry, maybe it might be a good idea to offset this a little bit outside the geometry so that I can see this curve a little bit better. Let me also color the original geometry to something close to black. And probably bring out the converted lines as well, colored in white. Merged it. And let's offset the colored tail curve a little bit outside the surface. So let's do this by using array node to copy the normal direction. Using the minimum distance for the point, other way around. And copy the intersected normal. And then move the point toward the normal direction a little bit. Point at P is equal to normal direction multiplied by a little bit of offset. Or you can also use something like polywire to thicken the frame. Okay. One thing I might want to control here is that I can see a dual curve here. I mean, I do have this underlying converted line here, as well as this line, animated line here. So maybe it might be a good idea to transfer the color information from this one to this one for the final result. Okay, if I look at the animation, looks pretty nice. Creating like a vein. And I can go back to the controller to, let's say, if I want to have more larger lengths. I think I forgot to promote these parameters. Well, I think I did. What was it called? Vein lengths right here. If I set it to 1, it's gonna be really long vein trail. Okay, looks nice. Now, but as I said, it might be a good idea to copy those information to this converted line so that I don't need to merge these together. So let's see how I can do this. Thing is that if I look at this offset, or if I look at this curve, the tail animation, you can see that some of those tails are, some of these trails are being merged, or I mean at the same position, like here. Okay, so I need to consider this one, like which color to pick for each position. Okay, I think it's a good idea to just get the largest value, in this case pick the more red color when it's overlaid together. So to do that, it's the best way. I can use the point wrangle node for the convert line. Maybe after resampled might be a good idea. After resampled, yeah, I don't think I need the color node. I can refer to detail animation and try to get the value attribute, this value attribute, at the same position. And then there is a chance that you get more than one value, more than 1 points at the same positions. So I can use a function like new points at the current point position using a maximum distance. Could be really small. And if you have multiple points, you can loop through all the points. And get the value and just get the maximum value. Use the maximum value out of those possible points. So let's create the maximum value variable starting from 0. Get the value from the second input at npt, and if the value is larger than the max value, then update the max value to the value. And then or you can just use the single function. Max val is max val, max val. And then finally you can set the current value to max val. Just like this. Transfer value. And let's try to color this using this color node and see if I'm getting the one that I want. So I think I have successfully transferred this trail animation or trail value on top of this converted line. And if I merge this, I have now this animated curve on top of this geometry, just like this. Alright, and if you want, you could still offset this a little bit outside to have a bit more cleaner, sharpy edges. Alright, I think that's pretty much it for what I wanted to show you today. Looks good enough. Okay, I think that's it. It's already been 3 hours. Sorry for being slow to implement. Today I did 2 main things. One is to create a iterative or recursive branch geometry, and one is to run this vein-like animation on top of this branch. Okay, I hope you find this interesting. Let me know if you have any comments or questions. If you have anything, I would like to answer it. If not, I'm going to end this live for today here. Since this is a replacement session for the Wednesday, which I have missed because of the weekly workshop I did at Kyoto, so I'm still going to do the next weekly tutorial on next Wednesday as well. Okay, so this is today's one is just a replacement weekly session, so that I don't miss the weekly, like, I don't know, weekly tutorial like lists. Okay. I don't think I have any more questions. Maybe I can end this tutorial here. I am going to archive this video so that people can watch this later on, and I am also going to upload the file that I've just created here, the same file that I have here right now, to the GitHub, and you can download the file from the link in the video description page later on, right after I finish this live. Also, if you are interested in supporting me, there's a Patreon page which you can access from the video description page as well. So if you're kind enough to support me, that would also be great. Okay, that's pretty much it. Thank you for joining, and see you next Wednesday, which is in 4 days or 3 days. And I haven't thought about what to create yet. Probably a day before or Wednesday or something like that. I'm gonna choose what to create. Okay, thank you very much and good night. I'm going to go to sleep after I have uploaded the file. Alright. Okay, see you, and hopefully you find this interesting. Okay.